Now let's see how we solve a problem J file in C++. Here, and this is the included files. We have L stream for input output. We have site to track the pages. We have vector to track the nodes in the tree. And we have a map for the page number to the page node in the tree. Then we have memory header. That's mainly for this shared pointer. You don't have to use it, but to make the memory management easier, you should use it. So here, and declare the namespace std, and then define the node structure. So in each node we have a value, and that is the page number. And also we have a vector of nodes, and that's the shared nodes in the tree, which is also the pages that we can jump to from the current page. And then we have a function find the shortest path, and this is to find the minimum pages you need to read to finish a story. And there are two parameters. The first is nodes. This is the page nodes to check, and also a level. The level means the level in the tree, and it also means how many pages you have read to get here. So first we increase the level as we are going one level down, and then we declare the shared nodes for further check, and then we have a loop to go through the nodes. If you don't like this format, you can write the traditional C++ for clause. It doesn't make much difference. So here we check whether we have any children or not. If we don't have any children, that means this is a leaf node, which is an ending page. And if we get to an ending page, and then we know that we get the shortest path, so we should return this level. This is the number of pages we have read till now. So this is the minimum pages we need to read to finish this story. Otherwise, if there are children, then this is not an ending page. And then we check the shared nodes, and then we call this function again. So this is a recurring function. It recurs on each level in the tree to get to the first leaf node. And then we have another function, get reachable pages. So this function starts from page 1 and then goes through all the shared nodes to get all the reachable pages. We have two params. The first one is a node to check, and then the second is a set, which is for the reachable pages. So in the function, first we check whether the current node, whether the page for the current node is already checked. If it is, that means there is a loop. We should check no more on this node. And if it's not checked yet, then we put this page into the set, and then we use a recurring on this page to check all the children. So this is this function, and then the main function, and this variable n is the number of pages in the book, and we read in this number n, and then we create a map for the k is the page number, and the value is the page node. We use a loop to initialize the map. So each page get its corresponding page node, and with the proper value, the page number. As we start from 0, so here we need to +1 for the page number. And then we do the loop again to read in each page. So first we read a number of jumping options on this page, and then we loop and read in each option and put it into the map. So now we have the map ready. Each page node in the map has all the references to all the page nodes jumping to, and then so after this loop, we have written all the numbers, so the book structure is built. And now we need to check the two functions. The first one, do we have all the pages reachable? And we declare a set, and then we call this function get reachable pages starting from page 1. And after this function returned, we have all the reachable pages in the set, and we know that in a set all the numbers are unique. So we check whether the size of the set equals n or not. If it equals, that means all the pages are reachable. Otherwise, there are some standalone pages, and we should print n. So this is for the first function. Then for the second function, we should find the shortest path. So we define a level as 0 as it is not started yet, and then we define a vector of nodes to check. In the first recurrent, only page 1 needs to be checked. So we put page 1 into the vector, and then we call this function find the shortest path. It should return the closest leaf node, which is the minimum number of pages we need to read to finish a story, and we print this number out. So this is the code for this problem, and now let's test it. And here we are ready to test the sample input 1, and we give 3, 2, 2, 3, and 0, and 0, and we got y and 2, which is exactly the output from the sample. So our program is working for sample 1. And now we are ready to test the sample 2, and we give 3, 2, 2, 3, 0, 1, and we get y and 2, which is exactly the output from the sample. So our program is also working for sample 2. So this means that our program is working well for this problem, and this is the solution to problem J5 in CCC 2018. Okay, that's it. I hope you guys enjoyed this video. Please thumb up and subscribe to my channel. I will have more videos on the problems soon. Thank you. I'll see you soon.